Hello guys, welcome back to Maths on African Motives, still on our mathematics for grade 11. This is a revision that we're going to have that is working with our equations and at the same time working with our inequalities. All right, so I want us to check some typical questions that we are given here, which are on equations and as well as the inequalities contain. All right, so we've got the first part of the question, which is to solve for x. All right, we've got this question, which is actually 2 marks. All right, that's a direct question that we are given them, whereby we are being asked to solve for x in this case, given 2x into x minus 3 is equal to 0, and we are asked to find or to solve for x. So what we simply have here is that we're going to apply our zero concept. Remember, the product of two numbers to be equal to 0. It means one of these numbers must be equal to 0, one of the terms, right? A must be equal to 0 or B must be equal to 0. So that is the condition, meaning to say 2x is supposed to be equivalent to what? To 0. We are supposed to equate this to 0, or the bracket of x minus 3 must be equal to 0. That is the condition. So meaning to say we can have the value of x here, just divide by 2 by 2. So that's x is equal to what? 0 divided by 2, that's a 0 there. Or x is equal to, if we transpose negative 3 to the other side, it's going to be a positive 3. So these are the possible values of x that we needed. 2 marks for that. All right, 1.12. So for x, again, correct to 2 decimal places. Whenever you are given this condition that you're supposed to write your answer to 2 decimal places, it means the solutions there, they are not exact. All right, so meaning to say whatever that you're going to have, we're supposed to either apply the quadratic formula or use of the use of the completing of the square method. All right, let us see how can we apply the quadratic formula first, then how can we use also the completing of the square method. 3x squared minus 2x is equal to 4. So what we can do is to transpose first. Remember, the format of the quadratic equation is given in the form of ax squared plus bx plus c is equal to 0. Meaning to say one of the sides must be equal to what? Must be equal to 0. So we are going to have this as 3x squared minus 2x. Transpose 4 to the other side, it becomes a negative, and that's a 0. So we have got the format of our quadratic equation that we know it can be solved using the formula. Remember, the formula, it states that x is equal to minus b plus or minus the square root of b squared minus 4ac. Everything is divided by what? By 2a. So that means we can have the value of x in this case, whereby we are simply saying, according to this format, a is the coefficient of x squared, which is what? Which is 3. So we are considering our a as 3, b the coefficient of x. We are considering this as negative 2, and c as the constant, and our c there, that's a negative what? A negative 4. So simply we are going to substitute whatever that you're given into the formula. So x is equal to minus b, that's minus our b, which is minus 2, plus or minus the square root of b squared, our b, that's minus 2. So you're going to have minus 2 squared minus 4 times a, our a in this case, which is 3, and c, which is what? Which is minus 4. And this whole part is going to be affected by divided by 2 times a, which is 2 times what? 2 times 3. So thus we are going to have the values of x from there. Okay, so meaning we're going to have x is equal to minus and a minus, that's a positive. So there we are going to obtain a positive 2. Plus or minus, so I want you to simplify this part here under the square, just the part. All right, just this part under the square root, this one under the square root only. All right, those values that are under the square root, only to simplify that on your calculator, you are going to obtain something like 52. All right, let me just bring this and say and show you what I'm trying to say here. On your calculator, this is just minus 2 squared. So we're going to have a bracket minus 2 squared. All right, minus 4 times a 3, in this case, times a negative 4 like this. All right, so this is going to give us a 52. All right, so we are going to obtain 52. So this is the square root of 52. Everything over what? 2 times 3, which is a 6. So from this stage, we can separate our solutions. As we can see that we've got a plus and a minus. From this part, we've got a plus and a minus. So what you do is that you can separate your solutions in terms of x. So x is going to be the one with a plus and the other one with a minus. So that part you can even simplify on your calculator. You can do that. All right, so let's try to see how we can have this on our calculator direct. Okay, so this is it. We're going to have a fraction 2 here. That's 2. We'll start with a plus. So that will be a plus in this case, the square root of 52. Everything over what? Over 6. All right, so this is going to give us this. We change this to a decimal. That's 1,535 and so on. So what you can do is that you can even use your calculator to round off. Remember, the answer is needed what? Correct to 2 decimal places. Correct to 2 decimal places. So you can do that on your calculator. We can round off our values to 2 decimal places. That is, just press here, shift. You go to the setup. All right, then fix this to 2 decimal places. You press 6 on fix. All right, then to 2 decimal places, you're going to press a 2. So meaning to say our answer is now fixed to 2 decimal places. So you're going to press this again, SD, so that it changes to a decimal. All right, so that's 1,54 to 2 decimal places. All right, so you're going to get 1,54 in this case, 1,54, or x is equal to what? We're just going to change this and put a negative in place of this plus, delete this and put a negative. That is going to be negative 0,87 directly to 2 decimal places. That is how we can fix our calculator. So you can fix your calculator to any decimal place. 2 decimal place, 3 decimal place, whatever, depending with what you're given on that particular question. So this was the use of the quadratic formula. But as we know that in our syllabus, we also have the application of the completing of the square method. So how can I use completing of the square method to solve such type of an equation? All right, so as for the completing of the square method, there is no need for us to transpose this 4 to the other side. Right? There's no need for us to do that. What we simply need in this case is to make sure that the coefficient, right, of x squared is a 1. The number that is multiplying x squared is a 1. So how can we achieve that? We divide by that number that is affecting what? X squared, which is 3. Divide by 3 each and every term. So this is going to give to be x squared. So this is another way by using what? Completing of the square method. So this will give us minus 2 over 3x. So this we can just write as minus 2 over 3x is equal to 4 over 3. All right, so how do I apply the completing of the square method? All right, so this is what you're going to need. You are going to need the square of half the coefficient of x. So you're going to need half the coefficient of x squared. The coefficient of what? The coefficient of x. So you're going to need half the coefficient of x. The coefficient of x is the term, the number that is affecting x. The number that is affecting x there is what? Minus 2/3. Minus 2 over 3. So we need half of that. That is half of minus 2 over 3. But you're supposed to square it. All right, so this is what you do. Instead of squaring this answer to obtain a single number or a single term. All right, I just want you to simplify this part inside of the bracket. All right, so this is what I'm trying to say. Meaning to say on our calculator, we have to change our calculator back to the normal mode. So it's shift, setup, 8 to return our calculator to the normal mode, just press 2. All right, so what I'm simply saying is that find half of minus 2/3. So this is 1 over 2 like this times negative 2 over 3. Negative 2 over 3. Just find half of that. All right, do not square anything. Just find half of that. So this is minus 1 over 3. All right, yes, we can square this value. Minus 1 over 3 to the exponent of 2 is going to give us 1 over 9, which is fine. But what I want you to do is that just leave it like that. Just leave it like that. This is the square that you have obtained from this. So what you do is that you add this both sides of the equation. You are going to add that square. Okay, so you are going to see the advantage of leaving it like that. We are going to add this both sides. So meaning to say this will be x squared minus 2 over 3x plus the square, this one, the square that we obtained, which is minus 1 over 3 squared. So this is going to give us the 4 over 3 that we are already having on the right-hand side, plus, remember, we're supposed to add this both sides of the equation. So we are going to also add the minus 1 over 3 to the exponent of what? Of 2, which is the same as the 1 over 9. We know that this is 1 over 9, which is true. Okay? But the reason that I'm keeping this is that it helps you so much whenever you're dealing with the completing of the square method. What you do is that you simply focus with the first term and the last term on the left-hand side where we have completed the square. So what we need in this case is to factorize this expression. We need to factorize this. So how so? How do we factorize this? All right, so you consider the first term being raised to the exponent of 2 and the last term that is being raised to the exponent of 2. Those are the ones that are important. So this is x and this is minus 1 over 3. So you're going to take this as x and the minus 1 over 3 as it is. You square everything just like that. You factorize this. You factorize that directly like that. You have to consider what is raised to the exponent of 2 on the first term and what is raised to the exponent of 2 on the last term. Just like that. You combine as it is. That's why I'm saying do not simplify this. Just so that you properly see the number, the term that is being raised to what? To the exponent of 2. But on the right-hand side, this one, this is not a quadratic expression this side. These are just normal numbers. So combine them. Use your calculator to combine these numbers to a single number. All right? So this is going to give us what? 13 over 9. So if we simplify properly, this is going to give us 13 over 9. Okay? Then the rest here is just a simplification. As we know, guys, we're given a square. How do we remove this square? We have to introduce the square root, which is the opposite. So you're going to introduce the square root both sides. So the square root removes the square. So the square is no longer there. So we remain with x minus a third, which is equal to what? Which is equal to the square root of this. So yes, we can simplify this, or you can just leave it like that. The square root of 13 over 9. But we all know that the square root of any number is what? It's a plus or minus. Whatever that you're going to get there, it's a plus or minus. For a square root, there are two possible values there. So in order now for us to have the value of x, what can we do? We can transpose the minus third to the other side of the equation. So when this number jumps the equal sign, what happens? The sign reverses, the sign changes, becomes a positive. So it was a minus this side. On the other side, it's going to be a positive. So x is going to be a positive a third. But already here, there's a plus or minus that was already there. Plus or minus what? The square root of this part, which is 13 over 9. That's the idea there. All right? So yes, you can simplify this. You have a number, then you combine it to be a single fraction. It's up to you, that part. You are not using the quadratic formula. You are using the completing of the square method. So you can even leave it like that. Okay, what you simply want is x. So here we can what? We can combine. There are two signs that are there. There's a plus and there's also what? A minus. So one of these is going to carry a plus and the other one a minus. We simplify. All right, so I'm just going to show you on the calculator here. But I think, guys, we now know how to apply this on our calculator and also how to fix our calculator to 2 decimal places. All right, so this is 1 over 3, all right, plus, there's a plus there, so you're going to have the square root of a fraction. So this is 13 over what? 13 over 9. So this is going to give us this decimal, as I talked about. This is fixing, so it's going to change to 1,54 if you round off to 2 decimal places. So that is going to be 1,54, or x is equal to the other part here. We're going to change this to what? To a negative. And this will give us negative 0,868, which is 0,87 to 2 decimal places. So as you can see, guys, we are obtaining the same answers just like the ones that we used from the quadratic formula. So it's up to you. Are you going to use the formula or completing of the square method? All right. So that was the condition of our question 1.13. Solve again for x. This one, we are now given an inequality in this case. All right. So we are given that 1.13, that's x minus 1 into 4 minus x is greater or equal to 0, like that. Okay. So how do I solve inequalities? That is the question. How do I solve inequalities? Okay. Already here, we are given a condition that gives us the critical values already. They're factorized for us. We know that from that condition, we can simply obtain what we call the critical values. What are the critical values? The critical values, these are the values that I'm obtaining, the x values, the solutions. When I'm solving this as an equation to say x minus 1 into 4 minus x must be equal to 0. Ignore the inequality sign. You ignore it. All right. You ignore the inequality sign. You find the x values, the solutions. So x is equal to 1 from this bracket, or from this bracket of 4 minus x is equal to 0. How can we find x? We transpose x this side. It means 4 is equal to positive x. If 4 is equal to x, what does it mean? It means x is equal to 4. If A is equal to B, it means B is equal to A. All right. So that is the condition that you're going to apply. So these are the critical values, the ones that you use to determine the solutions from the inequality. So either you're going to use the graphical method, you're using a number line and so forth. I don't know which method are you going to apply. All right, so I'm just going to apply two methods here for you. I'm just going to choose first. Let us take it from the graphical method. All right. From the graphical method, we are supposed to be very, very careful. Why? Because we are supposed to consider to say if we are given the equation or the inequality in the form of ax squared plus bx plus c, all right, maybe it's greater than 0 or it's less than or equal to 0 or whatever that you're given. Whatever that you have as an inequality must be taken from a function when it was a function first. When it was a function first. So when it was a function, if this a is a positive, if a is greater than a 0, meaning to say it's a positive value that we are talking about, gonna have what? A smiley shape like that. If our a is less than 0, which is a negative values, it means we're gonna have what? A sad shape like that. So that is important. So what affects the shape is the coefficient of x squared, the number that is affecting x squared. So how do you see it now? You just test to say, okay, don't expand everything on your brackets. Just test where x and x meets, because that is where x squared is formulated. You can't formulate x when x squared when x and 4 meet. There's no way. That would be a 4x. But x squared can be obtained if x and x meet like that. So that is how you test. So x times minus x, what do we obtain from this? We obtain minus x squared. So what does it tell us in terms of the shape? If it is a negative, it means we are going to have a sad one, this one, which is a sad shape. So on our graphical presentation, that is what is important. Do not expand everything. It's not important. No, it's not. What is important? What is the coefficient of x squared? So meaning to say, our shape is supposed to be what? We know the shape now. It is supposed to be like this. But where is it going to pass? At 1 and at 4. So let's say this is where we have our 1 and this is where we have our 4. So our function is going to pass like this at 1 and what? And 4. So this is our function. So the question is, when we are using the graphical method, which values, as we now have, are greater than or equal to 0? The values that are more than or equal to 0 are the values that are above of the x-axis when you are using the graphical method. Greater than or equal to 0. That is what? Above the x-axis. Above what? The x-axis. When it is less than, that is below the x-axis. So our solutions, they are supposed to be taken on top here, on top. So where are we going to have the solutions? Definitely these are the ones that are bounded by the graph here. These are the solutions that are in between the graph. So these solutions from 1 up to 4 in between, what do they state? They state that x is supposed to be greater than 1 as you are comparing our x. All right, 1, 2, 3. So our x is supposed to be greater than or equal to 1. But the same x compared to this 4, it must be what? Less than or equal to 4. It cannot be greater than 4. So these are the solutions that we're going to have. So therefore, in this case, our final solution is going to be x is greater than or equal to 1, but less than or equal to 4. So you have to understand your graphs. You have to understand the graphical presentation. All right, no problem. Let's try. Maybe you're gonna understand maybe you're gonna understand the number line concept. All right. So what I'm trying to explain is that how do you find the final solution from the given critical values, because you have got the critical values here. So okay, that's another method. You're using the number line. So what is happening on a number line is that you have to indicate the numbers that you're given. Remember your number your number line from your mathematics grade 10. If this is 1, this will be a 4. These are the solutions 1 and 4. So there's 1 and a 4. So we are now asking ourselves now to say the values that are taken from this point 1 here, going this side, how are they compared to x? These are the x values, as we know. These are the x values. But these x values, as you are going this side compared to 1, how are they compared to 1? Are they bigger than 1? We are comparing values such as 0, -1, -2, -3. How are they compared to to 1? They are less than 1. Okay? What about values that are in between 1 and 4, in between here? These values that are in between. So every values that are in between are taken as x is greater than the lower value, which is greater than or equal to 1, but less than or equal to 4. We only put this equal to this one. You see this equal to. We only put this equal to. All right, let me also indicate it here. We only put this equal to here when there is also an equal to on our question. If there was just a greater than there, we were not going to put this equal to here. We only put it because there is what? An equal to on our question. All right. Then what about the values that are from 4 to the right-hand side compared to 4? What are they? These values this side, they are bigger than 4. They are greater than 4. These values this side, they are greater than 4. But since there is an equal to, so we shall consider them as what? X is greater than or equal to 4. So our answer is supposed to be at one of these. Or maybe this one and this one, or one of these, we do not know. We do not know where our solution is going to be like. So you test the values. Do they maintain exactly this inequality that I'm given here? Because you are comparing with this situation here. This is the situation that you are using, remember. This is the situation that you are using here. That x, okay, so our situation is this one. 4 minus, this is 1 minus x minus 1. X minus 1 into 4 minus x. We must obtain what? We must obtain values that are greater than, that are bigger than or equal to 0. Meaning to say our answer is supposed to be what? A positive, greater than a 0, guys. That's a positive. So using a number line, you can test now to say, okay, here I'm comparing values that are less than or equal to less than or equal to 1. Which values that you can think of? Values that are smaller than 1. There's a 0 there, there's a -1, there's a -2, there's a -3, there's a -4. Guys, it's your choice. But don't use 1, because 1 you are tempted because you are using the value that is at the critical point. Don't use the value that is at the critical point. Use any other value. So we can even use a 0 in that case. So what I'm simply saying is that for values that are less than 1, we are going to pick a 0 there. And we substitute a 0 here and check how our answer is going to correspond. Is it going to be a positive answer or not? If it is a positive, it means it satisfies the inequality. But if it is a negative, it's wrong. Okay, we said, let's use x is equal to what? When x is equal to 0. So in place of x, we're going to substitute a 0. So that's a bracket there, 0 minus 1. In place of x, sorry, that's 0 minus 1. In place of x here, into the bracket of 4 minus x. Remember, our x is 0. So that's 4 minus a 0 like that. So this is going to give us a negative 4. So if x is equal to 0, our answer is a negative 4. So what does it tell us? Is it correct? Is this a solution? No, because our inequality must be a positive. The answer is supposed to be greater than or equal to 0, a positive greater than or equal to 0. So any number that is less than or equal to 1 does not satisfy this inequality. So this is wrong because we are getting negative answers, of which we are supposed to get what? A positive answer. So this region is totally out. All right, we move on to the second region. From 1 up to 4, is there any value that is there between 1 and 4? 1, 2, 3, 4. Any value, you can even choose a 2 there in between. So you can choose our x here to be equal to what? To be equal to 2. So just like what we did here, we are going to substitute x is equal to 2 and see if our answer is going to be what? A positive. In place of x, let's substitute what? A 2. All right, so in place of x, you're going to substitute a 2. So remember, this is 2 x minus 1. So in place of x, going to just put a 2 here where there was x here. 2, going to put a 2 there. Also here, where there was our x previously, we're going to put a 2. So this is going to give us what? A 2. So if x is equal to 2, our answer is 2, which is a positive. So it means it satisfies our solution because our answer is a positive, it's not a negative. All right, let's try another one, 3, because it's part of the solution from 1 up to 4. 3 is also there. So in place of x, we're going to substitute what? A 3. All right, so let's bring our calculator in place of x. Sorry, here. All right, so I just need this. In place of x here, you're going to put a 3. In place of x, where there was an x, wherever there was x, we're going to put a 3. All right, this x here is this one, guys. Sorry, this is the x here. X minus 1. This one is a minus 1. This one it's a minus 1 here. Our x there is the 1. That is a 3. So the answer there is going to be a positive 2. If x is equal to what? If x is equal to 3, our answer is it's a positive. So as you can see, any value that is within this region, it gives us a positive. So it means this solution, it satisfies our answer. So that is our solution. We tried the last one. Do not say we are done. Okay, let's try the last one. If x is greater than or equal to 4, which value can we think that are bigger than or equal to 4? We can think of 5, 6, and so on. So let's just try if x is equal to 5. All right, if x is equal to 5 here, in place of x, remember, this is 4 minus x. So it's 4 minus 5. All right, then x minus 1. So this side is x minus 1, which is 5 minus 1. Did I show the screen? Okay, sorry, guys. I'm going to show the screen here. So this will be 5 minus 1. So as you can see, we get a negative 4. A negative, not a positive. It's a negative. So this is wrong because our answer is supposed to be what? A positive, to say it satisfies this inequality, because it states that the inequality of this nature, it is supposed to be greater than or equal to 0. So which part satisfied a condition of a positive? It is this mid one from 1 up to 4. So that is the one that we wrote previously. As you can see, we are obtaining the same answer. So you can use the graphical method. You can use the use of the number line, depending with which part you understand. All right, then on 1.14, it is to solve for x. All right, so these are equations also that we see under the application of sets when we are given square roots. So we've got the square root of 5 minus x, which is equal to x plus 1. So how do we remove the square root? We said to remove a square, you introduce the square root. What if there's a square root like this? You introduce the square, both sides. So you're going to square this. So that means we have removed the square root. So 5 minus x must be equal to x plus 1 squared. Meaning to say, we expand x plus 1 squared, remember we talked about the bracket of x plus y squared, which gives us x squared plus 2xy plus y squared, which is the first term squared, the first squared, which is x. So that will be x squared plus 2 times the product of xy. So it's going to be 2 times the first and last. The first, it's x times the last, which is 1. So this will be 2x. So that's plus 2x plus the last squared, y squared, 1 to the exponent of 2, which is what? Which is 1. Or you can just open 2 brackets and expand them properly. You're going to get the same answer. It's up to you on your simplification. So as you can see, what is on the right-hand side is the same as what is on the left-hand side. So I can even start writing from this where there is the x squared. So I'm just going to write this as x squared plus 2x plus 1 is equal to what we already have previously, which is 5 minus x. So how can I solve for x? All right. So this here, I've got x squared. I do not have any like term. But in terms of x and x here, I've got x and x there. So I can transpose the minus x to the other side. Remember, one of the sides of the quadratic equation must be equal to 0. So if we transpose this, that will be a positive there. So that will be 2x plus x, which is what? 3x. All right, 2 plus 1. Then on this other hand, we transpose the 5 to the other end, it becomes a negative. So this is 1 minus 5, which is going to give us what? A negative 4. So that's a negative 4 is equal to what? Is equal to 0. So as you can see, we have a quadratic, a normal quadratic equation. So are we going to use the quadratic formula? No, guys, here let us just try to factorize. As we can see here, the highest, the coefficient of x squared is a 1. So you can simply factorize this by having 2 brackets, x and x, so that if you multiply x and x, you get what? X squared. So what you do is that you focus with the constant, which is minus 4. Do we have factors of what? Negative 4. But these factors of negative 4 should give us positive 3. We need products. All right. If we multiply 4 and negative 1, we get a negative 4, which is true. If we add 4 plus minus 1, we get a 3. But check this one, minus 4 and a 1. If we multiply this number, yes, truly we are getting a negative 4. But if we add this number, minus 4 plus 1, if you add like this plus, you are going to get a negative 3, not a positive 3. So this is not our solution, but the solution is the first one. If you add 4 plus minus 1, we get a positive 3. So these are the numbers that we want. A positive 4 and what? A negative 1. So what does it mean? It means one of these brackets must be equal to 0 from the 0 concept. It means either the bracket of x plus 4 must be equal to 0 or the bracket of x minus 1 must be equal to 0. So x will be equal to what? Transpose this. That will be a negative 4. Or x is going to be transpose this. That will be a positive 1. And we need to test our values. Is this part satisfying our inequality? All right. So if we are to put our x as a minus here, as a minus 4, this is what's going to happen here. All right, let's have our calculator. I want you to see something. There we are given the square root of 5 minus x. So it's going to be the square root of 5 minus our x. Our x is what? It's minus 4. So it will be minus a 4 like this. All right, so this is what we get. We get a positive 3. This is what we get. On the left-hand side, we are getting what? A positive 3. But let's substitute to the right-hand side now. To the right-hand side, what was our given question? It was just x plus 1. Remember, the squaring was for us to remove the square root. It was just x plus 1. So if we substitute in place of x here, remember our x is what? Minus 4. Minus 4 plus 1 is what? It's minus 3. Is 3 equal to minus 3? No. 3 cannot be equal to minus 3. So this is not a solution. It's wrong. It can't be. 3 is not equal to minus 3. So this is totally out. You move on to the next one and test. If x is equal to 1 here, we're going to have the square root of 4, 5 minus 1. So we said our x is 1. So it's going to be 5 minus 1, which is 4. Square root of what? Square root of 4, which is 2. We substitute here 1 plus 1. 1 plus 1 is what? Is 2. 2 is equal to, is it true? Yes, it's true. So meaning to say the 1 there is a solution that we are given at the end. So this is actually our solution, but this cannot be our x. It does not satisfy the given condition. That is how you answer these questions. All right, so that's 1.14. Let us check another question, 1.2. There we are given to solve for x and y simultaneously, considering the simultaneous equations. All right, so we've got the first equation here, which is x plus 4 is equal to 2y, and the other one, that is y squared minus xy plus 21 is equal to 0. So how you solve your equations is up to you. It's up to you. How well do you understand this? All right, so I've got two equations here, the first equation and the second equation. So I can make from the first equation, because it's easier here, I can make x the subject. So you can simply make x the subject of the formula. So by making x the subject, what does it mean? It means x is going to be equal to 2y, which is already there on the right-hand side. So this is 2y minus what? Minus 4. So this is the x that is formulating equation 3, and we're going to substitute equation 3 in what? In 2. You do not substitute where you formulated that x to be the subject from equation 1. No. You are going to substitute in what? Equation 3. So you're going to substitute equation 3 into what? Into 2. All right, into equation 2. So wherever there is x, we're going to put what? This expression. So this will be y squared minus xy is the same as minus yx. So it's minus y times x. X is what? Is 2y minus 4 plus 21 is equal to what? To 0. So there we are now having an equation that is we are just left with y there. But you have to simplify further this and that so that you can be able to solve properly. Expand your brackets. That will be y squared minus y times 2y is going to be minus 2y squared. Okay, minus, that will be a positive. So that's positive 4y in this case, plus 21 is equal to 0. So you're going to subtract 1 minus 2, which is minus 1. So that's minus y squared plus 4y plus 21 is equal to 0. This is a normal quadratic equation that we have. But as you can see, we can even make the coefficient of y squared to be what? A positive. So you're going to divide by -1, by -1, by -1, by -1 throughout. So that means you're going to have y squared, positive, negative, that's a negative. Positive, negative, that's a negative, is equal to 0. Y 0 divided by any number, that's a 0. So the question is, do we have factors in this case? Because what we have here is that we can factorize the coefficient of y squared is just a 1. So we can have two brackets direct there. Equal to 0. Since it is an equation, we are not just factorizing. So that's a y there and a y there. Remember what I said, where do you focus? You focus on the constant. Do we have products there, factors of -21? But these two numbers, when you add them, they must give you a -4. Two numbers, when multiplied, you get what? -21. But when added, you get a -4. So it's a trial and error. You try as many numbers as, but as you can see, the possibility of having a 4, it's on 7 and 3. But how best are you going to have this 7 and 3? To get a -21, it means 7 can be a negative or 3 can be a negative. That is what we know. So if we multiply this, we get -21. If we multiply this, we get -21. But which part, when we add, we are going to get what? -4. If we add, that is the condition there. If we add, you must get a -4. So if we add these two, truly here, we're going to get a -4. But if we add these two, we're going to get a +4, not a negative. So the ones that are giving us a -4 is -7 and what? -7 and a 3. So here we're going to have y -7, y +3. All right, that's a -7, sorry. y minus 7 here, and y plus 3 is equal to 0. So from the 0 concept, remember I talked about this, guys. One of these brackets must be equal to 0. So y is going to be a positive 7, or y is going to be, if we transpose this to the other side, it gives us a negative 3. So from these two solutions that we have, we can determine the value of x, the values of x. Already x here is the subject. We made x the subject of the formula. So it's just a matter of substitution there to obtain what? The x values. We already have our x as the subject. Remember we said x is equal to what? 2y minus 4. So the condition is that if y is equal to 7, what is the value of x? If y is equal to 7. All right? What is going to be the value of x? Okay? So that means in place of y, you're going to substitute a 7. So x is going to be 2 times 7 minus 4. Or we have a condition when y is minus 3. So x is going to be 2 times y in this case, which is minus 3 minus 4. So this gives us the values of what? The values of x. So 2 times 7, 14 minus this is going to be a 10. Or x will be negative 10. All right? Minus 6 minus 4. That's minus 10. Or just use your calculator direct. All right. So with this information that we are given here, what does it tell us? It tells us when x was equivalent to 10, at that condition, y was what? We got this when y was equal to 7. And on a condition where x is equal to negative 10, what is the condition of y there? Y was equal to negative 3. So that is the condition that we are simply talking about. So guys, you must be used with your inequalities. I mean, with your simultaneous equations, how to solve these equations. All right, let us check the other part. So that was the simultaneous 6 marks for that. All right, 1.3, they are now asking us to discuss the nature of roots of this equation. All right, to discuss this, there are 2 ways that you can have if you're given this type of an equation. You can try to solve it. 2 into x minus 3 squared plus 2 is equal to, how do you solve this? We can transpose this to the other side. That will be x minus 3 squared is equal to minus 2. Divide by 2, divide by 2 in this case. So this will be x minus 3 squared is equal to 2, and minus 2, remember this is a negative, it's going to give us what? A negative 1. Okay. So if you are to solve here, what are you going to do? You are going to introduce the square root to the square root like this. Then you see that, all right, there's a square root of a negative number. Do we have the square root of a negative number? No. It means we do not have solutions if it is like that. Because we do not have what? The square root of a negative number. So we are simply saying our solutions, they are non-real. There are no solutions there. All right? We can't determine the square root of negative 1. Okay, but we are used with like this way of finding the discriminant, the b squared minus 4ac. But in order for you to properly see this discriminant, it is from the equation ax squared plus bx plus c, so that we can properly see our a, b, and c. Without this, we can't have b squared minus 4ac. So meaning to say we have to expand the brackets so that you'll be able to see this part of b squared minus 4ac. All right, so how do we expand our brackets? So this will be 2 into, expand x minus 3. So like I said, you're going to use that condition of having the first term. So you raise the first term to the exponent of 2. That's x squared. All right, minus the product. So it's going to be 2 times the first term, which is x, times the last term, which is 3. So if you multiply this, that will be 6x. So that's minus 6x plus the last term squared, which is 3 squared. 3 squared is what? It's a 9. Or you can just expand your brackets properly. Open 2 brackets, x minus 3 and x minus 3. From the for you method, x is going to multiply everything. X here, x times x, that will be x squared. X times minus 3, minus 3x, minus 3x times minus 3 times x, minus 3x. Minus 3 times minus 3, a positive 9. If you simplify this, you're going to get this. All right? So this is what we have, but there's already a +2 there. Take note. There's a +2, which is not even part of the bracket. So you can expand our brackets, multiply by 2. That's 2x squared minus 2 times this 6 is going to be minus 12x plus 2 times 9, which is 18, plus 2 is equal to 0. They are like terms there. So this will be 2x squared minus 12x. If we add this, that will be a plus 20 is equal to 0. So this is our equation. Yes, we can even reduce our equation and say by 2, but this one is up to you guys. It's up to you, this one. All right, let me just reduce x squared minus what? 6x plus what? Plus a 10, like this is equal to 0. So as now we have our normal quadratic equation, it means we can have the discriminant because we are saying the nature of roots are determined from what? B squared minus 4a. So you have to compare. Is it equal to 0? Is it greater than 0? Is it less than 0? All right. So from this, got the coefficient of x squared, which is our a, the coefficient of x, which is our b, and c is the constant. So b squared, that's minus 6 squared minus 4 times a, the coefficient of x squared, which is 1, times c, which is the constant, which is 10. So this is the part of the discriminant only. All right. The discriminant only. So this was going to give us a -4. So we know that if our discriminant, which is the nature of root that one, is less than a 0, that means we are talking about values that do not exist. Remember your conditions. When it is greater than 0, we've got solutions. When it is greater than or equal to 0, they are now perfect solutions. So on this one, if the discriminant is less than a 0 like this, it means there are no real roots in this case, all right? So these are simply non-real roots. They do not exist. We talk about negative numbers. Those are the ones that we are going to have there. When it is less than a 0, it means we are talking about what? A negative number, and you can't determine the square root of a negative number. All right. So that is the idea there. All right. Then 1.4 still, they are still on the nature of roots if you check. All right. This is now different. There is about the maximum value. All right. How do you determine the maximum value of a certain function? If we are given a function of f of x, which is equal to ax squared plus bx plus c. Remember, it states that at the maximum value or at the maximum turning point or minimum turning point or maximum value, the value of x is equal to minus b over 2a. At the maximum or minimum turning point, x will be equal to minus b over 2a, provided that we have this type of a format. So there we are given gx in this case. Already we've got our format gx, which is following the same format, minus 2x squared minus px plus 3. So if we check here, we just need b and what? And a. So the x of the turning point, it's minus b. What is b? The coefficient of what? Of x. What is our coefficient of x here? It's minus what? Minus p. Over 2 times a, which is the coefficient of x squared, which is what? Minus 2. Minus, minus, that's a positive. So it's going to be 2 times minus 2, which is what? Which is a minus 4. So this simply means we've got minus p over 4. If you want to use this, we've got minus p over 4 for the simplification purposes. All right. So what are we going to do with this minus p over 4? This is the value of x at the turning point, which means at the maximum value. But the question is, we are supposed to determine the value of p when it has a maximum value of 3 and 1 over 8. So meaning to say, when our x is what? Minus p over 4, that's where we obtain the maximum value. So what does it mean? It means the g of minus p over 4, where x is minus p over 4, we must get the answer, which is the one that we are given as our maximum value, 3 and 1 over 8. All right. So this is going to be written as what? 25 over 8 from that 3 and 1 over 8. All right. So this will be from the values of what? Of y. This is 3 and 1 over 8. Take note. So it's going to be 25 over 8, this one. Multiply 8 times 3, 24 plus 1, which is 25. So that's 25 over what? 25 over 8. So what does it mean? It means in place of x, g of, in place of x, we're going to suppose we have this as our x. So where there's x, we're going to substitute what? Minus p over 4. Where in this equation that we are given here, from our gx, remember, we are talking from the gx. So it means in place of x, we're going to have minus 2 times x squared. Our x is now given as what? Minus p over 4. So it's going to be minus p over 4 squared. Minus p times x. Our x is given as what? We are substituting the value of x there, which is minus p over what? Minus p over 4. Plus a 3. This must be equal to what we already have as our maximum value, the value of y at the what? At the maximum point. So we have formed an equation that we are supposed to solve for what? That we are supposed to solve for p. All right. So how do we solve? This is now you guys and your understanding of the equations. But as you can see, you can raise this to the exponent of 2. That will be minus 2 times minus p over 4 raised to the exponent. Everything is being raised to the exponent of 2. So that will be minus 2 over p squared over 4 squared, which is what? Which is 16. All right. Then you can multiply here. This is the same as over 1. So it's minus p times minus p. That will be a positive p squared over 4. Then we can even transpose 3 to the other side of the equation. Or you can just leave it like that. We do not know what's going to happen on this. Okay. Then taking this side, we can combine that to be a single term. This is minus 2 plus p squared over 6. If you simplify this, this is p squared. This is p squared. So meaning to say we are simply adding minus 2 over 16. This is what you're simply focusing on. Minus 2 over what? Over 16. Plus the 1 over 4, because everything is for p squared. All right? Everything is what? For p squared. So these are like terms. So you just have to add the coefficients there of what? Of those like terms. So this is minus 2 over 16 like this on your calculator, plus 1 over 4. So this will be 1 over 4 like this. So you're going to get negative 1 over 8. So this is positive 1 over 8. And take note that this 1 over 8 is the part of p squared. So it's going to be positive 1 over 8 of p squared. Take note. 1 over 8 of what? Of p squared. So this is what we're going to have, which is equal to what? We can even transpose the 3 to the other side of the equation. It becomes what? A negative there. So this is 25 over 8 minus 3, and that is going to give us 1 over 8 if we subtract properly. 25 here. All right, let me just show you. 25 over 8 minus what? Minus a 3 like this. This will give us 1 over 8. So since we want the value of p in this case, we can divide by 1 over 8 both sides. So this will cancel. So p squared will be equal to, if we divide by 1 over 8 by 1 over 8, this will be a 1. We have divided by 1 over 8 by 1 over 8. But it's the same, guys. This will cancel, we get a 1. So how do you find p? Introduce the square root, and we know that the square root of any number is what? It's plus or minus. So p is going to be given as what? Plus or minus 1. All right, so this is going to be the value of p, plus or minus 1. These are the possible values of p that will satisfy the condition that we are given there. The condition that we are given there. So guys, we have to be very, very careful how we attempt our questions. So that was 26 marks, everything on this question. So as you prepare, you are supposed to go through your revisions depending with which part exactly are you revising towards. Are you revising just equations? Are you revising inequalities? But these are the typical questions that we shall bring you guys from Mid-Zone African Motives till we meet again.